Welcome to the Databricks Skill Builder series. We're glad you're here.
Perfect. Nice to meet everybody. My name's JD Braun. I'm a part of our platform and infrastructure specialist solutions architect team here at Databricks, specialize in helping customers on deploying, integrating Databricks within their general AWS ecosystem. I also have two of my teammates, Ryan and Hao Ming, here as well. So if there are any questions in chat or anything like that, feel free to ask and they'll be patrolling there. So today's session, we'll be deploying Databricks with AWS PrivateLink and talking about the key components of what goes into a Databricks on AWS deployment. So first things first, what I'll do is I'm going to start off with hitting the whiteboard, and we're going to whiteboard what Databricks looks like and how our networking architecture works to set the stage. And then we'll go through the key components. So we'll start with the IAM, the cross-account role that allows Databricks or users in the Databricks workspace to spin up clusters within the customers or your AWS account. The second will be the root bucket. So this is the bucket for workspace assets that's added. And then last is the networking configuration. We'll talk about the VPC, the subnets, and then of course, PrivateLink, which is why we're all here. All right, so let me go ahead and start off by sharing my screen. All right, Ryan or Stephanie, would one of y'all mind letting me know if you can see it?
We can see your screen.
Perfect. All right, so yeah, let's start off just talking about the Databricks architecture and what it looks like. So as some of you may know on the call, Databricks, we operate with a control plane, data plane architecture for a classic data plane setup. What that looks like is we have a Databricks control plane that will host web app assets and other control plane resources. And then we have our data plane. And the data plane is deployed within your AWS environment. You'll register a number of assets with us, pointing to where these clusters are going to be spinning up. So within that data plane, when the clusters are spinning up, they'll be spinning up within private subnets that exist within your data plane. So I'm going to do a couple subnets here. And we'll add some clusters. Cluster 1, cluster 2. So those clusters are spun up using what we call the cross-account role. This cross-account role is a IAM role that establishes a trust policy with Databricks. And we can scope it down to add in, scope it down to the VPC, subnet, to the security group level when they're spun up. So what that looks like is a user, and we'll call this our user. We'll enter into the control plane, so to the web app, the standard Databricks web console that I'm sure many of you are familiar with. And once they click create cluster, what will happen is using the IAM role that you've registered with us, we'll generate short-term tokens to spin up clusters within the parameters that you gave us. So within the VPC, within the subnet, within the security group. So we'll take it like this, and we'll just do 2 arrows going to there. And we'll put. So when those clusters are spinning up, something unique and something that I like talking about with my customers is that these clusters or these EC2 instances have no public IP associated with them. They're spun up within private subnets. And when they first come up, what they're going to do is try and instantiate a connection out to the control plane. So it's called our secure cluster connectivity relay, and it will go outbound to that control plane, like I mentioned. And once that connection is established, then folks can carry on their normal jobs of clicking away at code, writing Spark, writing SQL, dashboards, all that. So we can write the connection path straight outwards. So now we think about this connection outwards. And some of our common deployments, what will happen is this outbound connection will go through the private subnet, route to a public subnet with a NAT gateway, have the get natted thanks to that NAT gateway, and then go out to the IGW. And then once it hits our internet gateway and goes out, it will make its way to the control plane. So going over the public internet with TLS encryption. Now, something that AWS has released in recent years is a service called PrivateLink. And PrivateLink is a backbone connectivity using VPC endpoints that allows you to privately connect from two different services. So instead of going over the public internet, right here, we'll call this this gap, the public internet, it's going to go over VPC endpoints. So we'll add a control plane. We'll go down here. We'll add another control plane. And we'll add a VPC endpoint service here, a VPC endpoint service here. So instead of the cluster going out that way to the control plane through your public subnet, your NAT gateway, your internet gateway, it's going to go outbound through the VPC endpoint using private DNS resolution. So very slick of being able to keep all that traffic over AWS PrivateLink. So like I mentioned, once it goes over that PrivateLink connection, the cluster will spin up and you're able to continue on with writing code or going about your day-to-day data engineering, data scientist, machine learning, engineer lifecycle. So now let's go ahead and I'll check the chat quickly and see if there are any questions. Looks like none right now, so no problem. So we'll go ahead and continue to create our workspace using PrivateLink. So first things first, like I mentioned, that first critical piece is the IAM role. I have my IAM role here. I have a policy, and this policy is going to allow it to spin up EC2 instances within those subnets, like I mentioned. We have scope down policies available on our Databricks website that scope it down to the security group, VPC subnets, etc. So not all star when resources that don't need it. And the important part here is the trust relationship. So the trust relationship with the Databricks role that is available on our website, this is public information, and then adding your external ID to this policy as well to prevent that confused deputy problem that may occur within AWS systems with trusted relationships. And this external ID is just your account console ID. So first things first, we're going to register this within the Databricks account console. For those of you who may not be familiar, our account console is our overarching object that you'll see all of your workspaces underneath it when they're spun up. Your Unity catalog will be available here. Your identities will be available here with Unity catalog for identity federation to push down, and all of your cloud resources that you're going to be creating and assigning to each individual workspace. So first and foremost, I'm going to go to my credential configuration and I'm going to click add. My credential configuration will be Databricks demo. And I'll go ahead and enter that ARN. Easy as that. First key part checked out. The next part is our root bucket. So this is not a data bucket. This isn't a bucket that's going to contain your production assets. This is purely a bucket that's going to have workspace assets. So different parts within your journey of using the account console that are stored within your account. So as easy as grabbing the name, going back to the account console, and adding it as a storage configuration. Something I like to call out with the Databricks root bucket for Workspace, what makes it what it is its bucket policy. So in the bucket policy, you're going to see the role from Databricks, similar to the trust policy on the cross account role, have access to this bucket, and then the condition, of course, reducing to that Databricks account ID that's passed into it. All right, so we've conquered the IAM role, the root bucket. Now let's talk about the networking configuration. So like I mentioned in my earlier drawing, the key parts are the VPC. So we'll consider this our VPC, a minimum of 2 private subnets that exist in different availability zones, a security group that's going to be attached to the EC2 instances, and then in the case of PrivateLink, the 2 VPC endpoints. So first things first, let's go ahead and register the VPC endpoints that we were going to be using for our PrivateLink connection. So you can find these at our supported regions on our Databricks documentation, where we'll list out the PrivateLink endpoint for each individual region. And there's going to be 2 of them. The first is going to be for the REST API, for the Workspace REST API. This is also used for front-end PrivateLink connectivity. If you want to route your users from, say, a on-premises through Direct Connect to this VPC endpoint instead of going through the public internet. So it has 2 uses, both for the cluster and for the users. The next is our secure cluster connectivity relay. So that initial relay that's going out from the data plane to the control plane that allows that code to be passed to and from. So let's start. We're in US East 1. So I'm going to grab the REST API. I'm going to navigate to my VPC endpoints and go ahead and create an endpoint. We'll give it a name, REST API Databricks, and click PrivateLink Ready Partner Services. Enter in, making sure I grab the right one. Yeah. Verify service. I'll select my VPC. I'll select the 2 availability zones. So I have PrivateLink Subnet 1A and PrivateLink Subnet 1B. Now I'm going to attach it to the security group so that any traffic within the same security group, and I'll go through this next, has access to each other. So with that, I'm going to go ahead and create endpoint. Endpoint's creating. Let's repeat this once more. Let's go ahead and create one for the secure cluster connectivity relay. I'll do SCC Databricks. PrivateLink Ready Partner. Service name. Verify service. Go to that VPC. AZ1, AZ2, put them in the PrivateLink subnets, and attach the security group. All right, so those are going to start coming on. Goes through a pending state, and we're going to revisit this in a second. Now, while we have these endpoints, let's look at the general networking topology that we have set up. So here, you're going to see my Databricks demo VPC. I'm going to have a total of 6 different subnets. 2 are going to be for the workspace. So where the clusters will actually live and spin up. This is going to be my workspace subnet 1A and workspace subnet 1B. When you create your subnets for your workspaces, you'll want to make sure that you size them appropriately. Each node of a cluster will require 2 private IP addresses. So if you do a /22, you'll take the available number of IPs there, remove about 5 or 6 of what AWS takes, and then divide that by 2. And you have the maximum size node you can create within that subnet, or maximum size cluster you can create within that subnet. Next, I have our public subnets, of course. So this is where our NAT gateways are going to be housed, because like I mentioned, all of this traffic that's coming from our cluster is outbound. So we'll want to make sure that's routing out to that NAT gateway, internet gateway, if we want our users to be interacting, say, with PyPy, Maven, public APIs, that kind of thing. We want to have a route for these workspaces to get out, or these clusters to get out into the public internet. And then, of course, 2 PrivateLink subnets, where I'm including the interface endpoints for the Databricks services, STS, and Kinesis. That is our general VPC setup. Some may look a little bit different. Some may centralize their VPC endpoints. Some may use transit gateways and do a central hub and spoke and use a firewall. So one of the things that I truly enjoy about talking about networking and security here at Databricks is just the flexibility we have to fit within a wide variety of AWS infrastructure and ecosystems. Now we've talked about our VPC, let's talk about our security group. So this is a security group that's going to be attached to our clusters on spin up. The rules are a little specific. For inbound, the only inbound rules are from traffic within the same security group. Because like I mentioned, traffic's only going outbound. We're going to have inbound to allow cluster communication with each other. So you think of driver, worker, node communication, as well as communication to other services. So if you think of SDS, Kinesis, etc., we want them all within the same inbound rule. So if you have a STS interface endpoint, Databricks cluster can talk to it. Outbound rules are going to look somewhat similar. We're going to have two that allow all traffic within the same security group, like I mentioned, interface endpoints, cluster connectivity, etc., as well as 443. So common HTTPS communication, if you're talking out to the public internet for PyPy, Maven, etc., public REST endpoints. 3306 for the Databricks default Hive Metastore, as well as Quad 6 for that PrivateLink connectivity. All right, now that we've gone over our security groups, let's revisit our VPC endpoints. Okay, our VPC endpoints are spun up. One more thing we have to do with these is we have to enable private DNS name. What this does is this going to add a name to this endpoint so that when the Databricks cluster is reaching out, it knows where to go. So it says, hey, I'm trying to reach nvirginia.privatelink.databricks. How do I reach that? The DNS name is going to be there. So we're going to do modify private DNS name again for the rest and allow these to come up. So now you're going to see our private DNS name of nvirginia.privatelink.cloud.databricks.com. So when these private link enabled clusters come up and they're ready, it's going to go outbound and it's going to find this. Otherwise, in non-private link enabled workspaces, it's just going to find the nvirginia.cloud.databricks.com instead over that NAT and internet gateway, like I mentioned before. Okay, so we'll let these come back into a available state. And in the meantime, let's get started with our networking configuration within the account console. So if we go to our network, we're going to start by doing a private access setting. This private access setting is required for all private link enabled workspaces. What this is going to do is it's going to dictate the behavior from a front end perspective. So if you want your users to not access Databricks from the public internet, you're going to set public access to false. If it's okay that they access from the public internet, that is to true. So some of the customers and companies that I work with, like I mentioned previously, will set up a direct connect into a VPC and route all traffic from their users' computers directly to this VPC endpoint using DNS resolution. So another improvement on the security posture. Now we also have IP access lists as well. So we have a number of different ways to restrict public traffic. So we're going to create our private access setting, Databricks demo, pass. Our region is US East 1. And we're going to turn this to true because we aren't setting up front end in this demo. And we're going to go ahead and add private access setting. Easy as that. Next thing is we're going to add our VPC endpoint. So the endpoints that we just created, we're going to go ahead and add those. So first, we're going to do our Databricks SCC, US East 1. And let's grab that endpoint ID. Great. We have our relay access. Now we're going to grab our REST. Great, easy as that. Both private link connectivities up and at 'em. Next thing is let's grab our networking configuration. So we're going to do Databricks network, VPC ID, our two subnets. Let's go and open our workspace subnets. Subnet 1A and subnet 1B. Exit out of those two screens. Next is our security group. Let's go ahead and grab our security group. And here's where we're going to set up this backend private link connectivity. So we're going to select our SCC and select our REST. Go ahead and click Add. So now we have our three components that we need to do to create a workspace. Now, before we create the workspace, I do want to talk about a number of the different options. So today I'm doing things manually within the AWS account console and within the Databricks account console. A lot of the customers will use Terraform, which fully supports this. We have a number of different examples at our Terraform examples for Databricks. We have one that supports PrivateLink. We have a data exfiltration firewall, and we have a basic setup as well, which will just spin up a couple subnets, couple public subnets, NAT, etc. for you. Other options for deploying it besides Terraform are CloudFormation. We also have a CloudFormation template that's available that can spin up all of this right off the bat. We have one that's embedded into the Databricks account console. That's what you'll see if you go to Databricks, to your workspaces, and the quick start recommended. It'll spin up a CloudFormation template, allow you to deploy. So if we boil down all the actions we're taking today, it is basically REST API calls in some capacity. So a lot of flexibility and simplicity to do it how you like to do it, how you like to deploy your workspace within your tooling. All right, so let's go ahead and create this workspace now. We're gonna do a custom AWS configuration. We're gonna do Databricks demo, region, we're gonna go US East 1, credential configuration, storage configuration. If I was enabling Unity Catalog today, I would flip this as yes as well. Network configuration, we're going to do Databricks network and add our private access setting. Okay, if we wanted to add in encryption keys, this is where we could as well. We offer two types of encryption keys, one for workspace storage. So that's going to be inclusive of your S3 bucket for your workspace assets, as well as EBS volumes that are attached to your EC2 instance. We have managed encryption as well. So encrypting any assets that exist within the Databricks control plane. All right, let's go ahead and click Save. And if we refresh the screen, we're going to be seeing that this workspace is coming up. So this will take a second or two. In the meantime, are there any questions that I can answer for anyone? We're approaching the end of the demo. What we'll do now is we'll just spin up a cluster using the interface and then go from there. And we can talk about some additional resources that we have. An option that I do like to talk about as this workspace is spinning up, when you click the workspace, you'll be able to see a nice view of everything that goes into each of your individual workspaces, from your credentials to your storage to your network. You can actually switch out the underlying networking configuration as well if you brought your own VPC to the workspace. So for a common case of this is if you have a development workspace and you're working on it and you want to spin up bigger and bigger clusters and you need to resize your subnets, you can do that. So again, a lot of flexibility to really create these workspaces how you would like to create them. Now, the last thing I want to cover is that as instances spin up and as you're working and creating your Databricks Workspace topology, a tool on AWS that I really recommend is the VPC Reachability Analyzer. If you are trying to connect to a Kafka instance, RDS, any kind of data tooling that you would normally hit with Spark, the Reachability Analyzer is a really nice tool where you can use an instance and point it to a VPC peering connection. You can point it to a STS, like interface endpoint, like I mentioned before, to make sure it can reach. So we'll take a brief look at that while we're waiting for our workspace to come up. So here, if I create an analyze path, you're going to put your path name. You'll do your source type, so your Databricks instances. I currently have none up right now. And you choose your destination from your VPN gateways, your VPC endpoints, transit gateways, etc. So as you're building out your network topology with Databricks, this tool allows you able to check within all these different services that you're using for setting up for your data engineers, machine learning engineers, etc. All right, workspace is up. Let's go ahead and sign in. And let's go into the compute tab. All right, so we're going to create compute. I'm just going to do a personal compute for this, a single node, and we'll go ahead and create cluster. So cluster is going to start spinning up. Last few things I want to talk about is we do have a new UI available in preview, which I recommend checking out. That simplifies our personas. If you go click Enable UI and you click Enable, you're going to see all of your commonly used SQL, data engineering, machine learning tabs right on your side pane. I really like it. I think it simplifies quite a bit of what I do in Databricks every day. All right. Last thing we'll show here is the EC2 instances as they're coming up. So we're seeing that our worker is in a running state. So if we went back to our reachability analyzer, and we do create and analyze path, and let's do a source of an instance. We'll do our worker that's spinning up, and we could select our VPC endpoints. We could select instances if we do a VPC endpoint and do our SCC. We can do create and analyze path, and we can see this path as it's going. So this is a great gut check to see, hey, is traffic making it to your PrivateLink endpoints as you set it up? We'll wait for this to run. As you can see, it's reachable, it's succeeded, and you get this really nice path detail of how it's gone through. So we can see our instance out through the ENI, through the security group, through the NACLs, route table points it to the VPC endpoint that's found in our PrivateLink subnet. All right, so that's it. Just to summarize, today we created a Databricks workspace with PrivateLink enabled to keep the traffic from the data plane as clusters are spinning up into the control plane using VPC endpoints. Last thing, of course, automation is still an option. Like I mentioned earlier in the call, check out our Terraform examples that simplify this entirely, or our CloudFormation templates. All right. I don't believe there are any questions, Stephanie, so I think we can end pretty early here. Oh, Stephanie, are you still there? All right, not a problem. Before I go ahead and end the webinar and pause the recording and we call it, Hao-Ming or Ryan, anything either of you two want to add from your experience setting this up or working with other customers?
The only thing, excuse me, the only thing I'd like to add, you mentioned that the tail end after we prove the clusters are working and all that, can't underscore enough the usefulness of using some automation like Terraform. JD went through a lot of clicks to do that manually. So Terraform is a great way to, one, reduce the amount of errors or eliminate the amount of errors, and two, to get this all set up in just a matter of a few minutes.
Absolutely. Hao-Ming, anything from your side?
Yeah, I think you pretty much cover everything that we need to do for workspace deployment. I don't have anything to add. But I think we do have a question here. Do you have a cloud template for this?
Oh, CloudFormation?
I believe it's referring to CloudFormation.
Yes. Yep, we do have a AWS CloudFormation template. So if we go ahead and I will start sharing my screen again. Give me 1 second as I pull it up. I'm going to share my screen one more time. Oh, cluster has came up, by the way, so we're up and running. I will put this link in the chat. This is a partner solution that we partnered with Databricks on, partner with AWS on from Databricks. And if we go ahead and create a new one with an IAM role, this CloudFormation template is going to allow you to specify PrivateLink, yes or no. And this GitHub is readily available for users to tweak, change, etc., and fully available. So another option that we have for deployment within CloudFormation. And to Ryan and Hao-Ming's point, from a Terraform perspective, I went ahead and pulled up a Terraform example here where I have my terminal. I'm gonna go and click yes. And this is creating everything automatically using Terraform. So highly recommend reducing any of the unnecessary steps like Ryan mentioned. So with CloudFormation, like we talked about, or Terraform, it's all being spun up, really reduces the step through. All right, well, I'm going to stop sharing again. And I think we will call an end to this webinar. Thank you all so much for joining. A couple of additional resources. Check out our documentation on enabling AWS PrivateLink, our customer managed VPC. And if you, of course, you have any questions, reach out to our Databricks community forum or your Databricks account team.